Hello, my name is Elijah and I will be presenting this project for Physics 115 involving refrigerators and temperatures. So the research question of this assignment is, at these operating temperatures of a refrigerator, what would be the maximum possible coefficient of performance for the refrigerator? This particular research question was inspired from section 11 of the textbook on eText, problem 50, question 50. The explanation of the physics here is that the coefficient of performance of a refrigerator is the ratio of the heat removed from the cold area to the work done on the refrigerator. Higher COPs, or coefficients of performance, mean higher efficiency, lower energy consumption, and lower operating costs. The coefficient is dependent on operating conditions, especially absolute temperature and the relative temperature of the area. The solving of this problem here, for my refrigerator in my kitchen, it was working at temperatures of 0 degrees Celsius inside and 24 degrees Celsius in the kitchen outside of it. The maximum possible coefficient of performance here was calculated using the formula below. COP equals TH divided by TH minus TC. TH is the absolute temperature of the hot area in Kelvin, and TC is the absolute temperature of the cold area, also in Kelvin. In this case, the hot area, which was my kitchen, was at 24 plus 273 equals 297 total Kelvin, and the cold area inside the refrigerator was 0 plus 273 equals 273 Kelvin. Plugging these values into the formula, we get 297 divided by 297 minus 273 equals 12.375. So in conclusion, the maximum possible coefficient of performance for my refrigerator operating at these temperatures was to be 12.375. The explanation of the simulation that I ran here was I used some coins in a glass and placed them in my refrigerator. After leaving them in the fridge for about 1 hour, I took them out of the fridge and measured the temperature of the inside of the fridge, the kitchen, and the coins themselves to help support the temperature difference. The inside of the fridge was 0 degrees Celsius, the kitchen was 24 degrees Celsius, and the temperature of the coins was around the same. It got low enough to support the temperature difference here. These are some pictures to prove that the experiment was conducted. A picture of the glass with the coins in it in the fridge, one outside of it, one picture of the glass outside of the refrigerator, and one picture of the refrigerator itself. The interpretation of this to connect physics to another subject involving refrigerators and the coefficient of performance, initially the problem revolves around physics, specifically the formula, but later it bears off into mathematics to get the final answer. To further interpret the mathematics involved in the refrigeration cycle, one must consider the ideal vapor compression refrigeration cycle. This cycle involves 4 stages: isenthalpic compression, constant pressure heat rejection, isenthalpic expansion, and constant pressure heat absorption. After all these are considered, then mathematics are used to solve the problem correctly, transitioning from the physics portion of the task to the mathematics. And that is my project here.